In this video, I'm going to go over the basics of generating a meshing script with the AutoLion3D GUI, and then I'm going to show how to use this script with ICEM to generate a fully functional 3D mesh for a battery. To get started, let's navigate to the mesh generation section of the AutoLion3D GUI. Here's where you can define the mesh resolution for the height and width of the cell. The higher the number of mesh nodes, the more detailed the output will be, but the longer the simulation time will be as well. Below, you can find sections to modify the size and location of the tabs for the cell, as well as the number of mesh grids for each tab. Once everything is set up, you can click the Generate Script button, which will generate this ICEM script in the working directory. This same process can be done for both RED and cylindrical cells as well. Once this is done, we can transport the parameters.xml file and the ICEM script to the Linux machine where we will get the full mesh generated. Start the mesh generation process by opening a terminal window in the location of the script file and run the following batch command in ICEM. In this case, I'll use the name of the script file we saved here. This process will automatically generate the preliminary attribute and geometry files for the mesh creation process. Once this is done, we can run ICEM and load in the unstructured mesh file, which contains the geometry followed by the ATR or attribute file. Once this is complete, we can export this data into a full mesh file by going to Output and filling out the appropriate name fields for the new file. When the entire process is done, there will be a bunch of new files generated in the folder, but the one we're really concerned with is the mesh file, which can be found here and is what we'll use to set up the case in Fluent. So once we have a mesh file, we can copy and paste this into our working folder for the simulation that we're going to run. Again, we'll open a terminal window for this folder and we'll run the SED pre-processing script, which will use the mesh file we just created to create a fully functional case file for Fluent. With this script, it's important to note that everything involved in setting up the case, including linking the AutoLion3D UDFs into Fluent, setting the material properties, and setting the time step will all be done automatically. The only thing that remains for the user to do is set the boundary conditions for the cell. This can be done by launching Fluent after the case is set up, navigating to the boundary conditions, and setting the desired conditions. An easy way to set the parameters for an entire group of zones is to use the copy feature, which filters out the irrelevant zones and applies the appropriate conditions only to the matching boundaries. Once this is done, we can initialize the simulation by setting the ambient temperature and, if desired, the type of output files from Fluent. We can initialize the simulation, confirm the operating conditions are correct, and then run the simulation. And that's it. Make sure to check out our other videos with more advanced features of the AutoLion3D software. Thanks for watching.